RGRல NEET கிளாஸ் படிச்சீங்கன்னா கவர்மெண்ட் கோட்டா சீட் உறுதிங்க. இல்லனா நீங்க கட்டக்கூடிய ஃபீஸ் ரீஃபண்ட் பண்றோம். எப்படின்னு பாக்குறீங்களா? 20 ஸ்டூடெண்ட் தாங்க ஒரு பேட்ச்க்கு. 16 மென்டர்ஸ் வந்து 20 ஸ்டூடெண்ட்க்கு சப்போர்ட் பண்ண போறாங்க. 6 மணில இருந்து நைட்டு 10:30 வரைக்கும் இந்த கிளாஸஸ் போகும். இதுல நீங்க ஒருத்தரா இருக்க போறீங்களா? ஜாயின் RGR அகாடமி.
Okay, my dear students, how can you apply integration concept in case of motion in a straight line? This is important concept. First of all, what are the mathematical concepts need for this? We have to study first. Followed by we'll do some numericals which are most important for NEET and JEE. What is integral dx? Integral dx is equal to what? X. Integral dx is equal to x. Second one, integral x power n into dx, that is equal to x power n plus 1 by n plus 1. Suppose the limits are given. Suppose I will take one example. Suppose if you take integral x square into dx, how can you apply this formula? Integral x square into dx. Integral x power n into dx is what? X power n plus 1 by n plus 1. Integral x power n into dx is x power n plus 1 by n plus 1. So that you can write, that is x power 2 plus 1 by 2 plus 1. We have to write like this. X power 2 plus 1 by 2 plus 1. So that you got what? That is equal to x cube by 3. That is equal to x cube by 3. Now, sometimes the limits are given in question. Integral 0 to 1. Integral 0 to 1, x square into dx is equal to what? Integral 0 to 1 x square into dx is what? Here 0 is called a lower limit. 0 is lower limit and 1 is upper limit. First of all, don't bother about these limits first. First of all, apply the integral formula first. What is integral x power n into dx? That is equal to x power n plus 1 by n plus 1. See, this is second formula. Integral x power n into dx is what? X power n plus 1 by n plus 1. So that you can write x power 2 plus 1 by 2 plus 1. After applying the integral, the limits will come to the right side like this. 0 to 1 will come like this. X power 2 plus 1 by 2 plus 1. So that you get what? That is equal to x cube by 3. What are the limits here? 0 to 1. First substitute upper limit. Here x is variable factor. In place of x, substitute upper limit. That is equal to what? 1 cube by 3 minus upper limit minus lower limit. X can be replaced by 0, 0 cube by 3. So that you get what? That is equal to 1 by 3. This is very, very important mathematical concept which is useful in motion in a straight line. Sometimes direct formula you can apply, sometimes limits also given. If the limits are given, how can you apply? First of all, apply integral formula. Integral x power n into dx is what? X power n plus 1 by n plus 1. So that it is x cube by 3. After applying the integral formula, the limits will come to the right side, 0 to 1. X is variable factor, so that we have to substitute upper limit first. That is 1 cube by 3 minus x can be replaced by 0. That is equal to 1 by 3. Right. Differentiation and integration plays an important role in case of motion in a straight line. Here, one technique is there. How can you differentiate here? Sometimes displacement is given in problem. If displacement is given in question, if displacement is given, how can you find velocity from that? Observe here careful. V is equal to dx by dt. The rate of displacement is called what? Velocity. If you differentiate with respect to time, then you get velocity from this. Because the rate of displacement is called what? Velocity. If you differentiate once again, second time differentiate it. If you differentiate once again, then you get acceleration. Because acceleration is what? Rate of change of velocity. That is differentiation concept in case of motion in a straight line. Similarly, how can you apply integral concept in motion in a straight line? It is quite reverse. Remember it careful. From displacement you got velocity, from velocity you got acceleration. Remember this order, then you feel it is easy. From displacement you got velocity, from velocity you got acceleration like this. Here integration is quite opposite. Suppose if we know the velocity v is equal to dx by dt. If you know the velocity, from that you get a distance traveled from this by applying integral concept C, which is quite reverse of this. If v is equal to dx by dt, from this you get dx is equal to what? V into dt. Observe here careful. Compare with the differentiation. Integration is quite reverse. From velocity you got a distance traveled like this. By taking velocity definition, v is equal to dx by dt. Do the cross multiplication. Therefore dx is equal to v into dt. Now do the integration on both sides. Integral dx is equal to what? Integral v into dt. But we have already studied mathematical formula. Integral dx is equal to x. So that x is equal to what? Integral v into dt. Sometimes the limits are given in question, we have to substitute the limits. And one more thing. See one more. Acceleration is what? Acceleration is what? The rate of change of velocity is called acceleration. Now try to compare now, then you feel comfortable. If you know velocity, acceleration, you can differentiate it. Because the rate of change of velocity is called acceleration. From velocity you got acceleration. Suppose acceleration is given in question. Acceleration is given question. Try to understand this point. If acceleration is given, from this velocity you got it. By doing the integration, which is quite reverse of differentiation. Now take this formula. Acceleration is equal to dv by dt. Now do the cross multiplication. That implies dv is equal to what? A into dt. dv is equal to a into dt. Do the integration on both sides. Integral dv is equal to what? Integral a into dt. Integral dv is equal to integral a into dt. Right. This is the shortcut method everyone should remember. Then you can do so many numericals based on this technique. See once again, if you know displacement or a distance traveled by the body, you got velocity by doing differentiation. V is equal to dx by dt. If you know velocity, from that you got acceleration. Differentiate it once again. You got acceleration dv by dt like this. See next, one more method, integration. Always not possible like this. Sometimes velocity is given, then calculate distance traveled. He will ask like this. At that stage, we have to apply the integral concept, which is quite reverse of this. Velocity v is equal to dx by dt. From this, you get dx is equal to v into dt. Do the integration on both sides like this. Integral dx is equal to integral v into dt. Right. If you know velocity, acceleration is what? Rate of change of velocity. That is called acceleration. Differentiate velocity, you got acceleration. But sometimes acceleration is given in question. Calculate velocity, he will ask, which is quite reverse of this integration. See here. A is equal to dv by dt. If you know the acceleration, from this you got velocity. A is equal to dv by dt. Do the cross multiplication. Therefore, dv becomes what? A into dt. Do the integration on both sides. Then you got the velocity from that. Right. This is the important concept. Followed by, we'll do some applications based on that. How can you apply integral concept in motion in a straight line? Right. Now, everyone observe this problem carefully. How can you apply the integral concept? See this particular problem. The velocity of a particle is given like this. The velocity of a particle is what? V is equal to at plus bt square. The velocity of a particle is like this. The velocity of a particle is given, one expression is given, where a and b are constants. Distance traveled between 1 second and 2 seconds. These are the limits. The limits are given like this. Lower limit and upper limit are given. 1 seconds to 2 seconds. Distance traveled is how much? Just now you discuss, if displacement is given, velocity is differentiation, rate of displacement. If velocity is given, acceleration is what? Differentiate once again. You got acceleration. But here, quite reverse. Velocity is given, distance traveled is what? Quite reverse is integration concept. That is the mathematical concept we have to remember. V is equal to at plus bt square. The distance traveled is what? You can take the distance traveled. You can take either a s or x. Whatever the letter you can take. No problem. Here, V is equal to at plus bt square. But velocity is what? The rate of displacement is called velocity. V is equal to dx by dt. Now, substitute V is equal to dx by dt. Therefore, dx by dt is equal to what? At plus bt square. Let us take this is 1 and 2. Here both left hand sides are equal, so that you can equate the right hand sides like this. Therefore, dx by dt is equal to what? At plus bt square. Do the cross multiplication now. Therefore, dx becomes what? At plus bt square into dt. Dx is equal to at plus bt square into dt. Now do the integration on both sides. Do the integration on both sides. Integral dx is equal to what? Integral at plus bt square into dt. Now everyone try to understand the question careful. The velocity of a particle is given, distance traveled between 1 second and 2 seconds. 1 second and 2 seconds means these are the limits given in question. 1 second is starting point, lower limit, and 2 seconds is taken as upper limit. Therefore, you can write the limits like this. The limits of time, observe right side, dt means time is variable, starting from 1 second to 2 seconds. These are the limits of time given in question. Between 1 second and 2 seconds. 1 second is the lower limit and 2 seconds is the upper limit. Right. And we have already well known integral dx is equal to what? Integral dx is equal to x. Right hand side, you can split into two separate integrals. How can you split? Integral 1 to 2 at into dt plus integral 1 to 2 bt square into dt. You can split into two separate integrals. And the limits are as usual 1 to 2 seconds. Therefore, x becomes what? We have already studied integral dx is equal to x. That is the distance travelled. Now, a can be taken outside, a into, just now we have already learned one mathematical formula. Integral x power n into dx is what? X power n plus 1 by n plus 1. Here t means power 1 is there. We have to assume power is 1. So that you can write t power 1 plus 1 by 1 plus 1. See here. I am writing that mathematical formula once again. Integral x power n into dx is what? X power n plus 1 by n plus 1. That is very, very important mathematical formula. See. Apply that formula now. T power 1 into dt, t power 1 plus 1 by 1 plus 1. So that you got t square by 2. What are the limits? The limits are 1 to 2 plus. Observe the second term. B can be taken out. Constant term. B can be taken out. B into integral t square into dt. Apply same formula. T square into dt, it becomes what? T cube by 3 between the limits what? 1 seconds to 2 seconds. Apply lower and upper limits like this. Now, that is equal to a into, after applying the integral, we have to apply the limits. Upper limit minus lower limit. Here t is variable factor. T is variable factor. T can be replaced by 2 first. That is 2 square by 2 minus. T can be replaced by 1. That is 1 square by 2. Upper limit minus lower limit. Here t is variable factor. So the t is replaced by 2 first. Upper limit 2 square by 2 minus. T can be replaced by what? 1. Minus 1 square by 2 plus b into, here also substitute upper limit minus lower limit. T can be replaced by 2 first. 2 cube by 3 minus, what is lower limit here? 1. That is what happened? That is 2 cube by 3 minus 1 cube by 3. We have to write like this. What happened further? You can write directly from this. Here 2 is taken as LCM. That is 2 square. 4 minus 1. This is 3 by 2 into A plus B into 2 cube is 8. 8 minus 1 is what? 7. What is the final answer? You got it. The distance traveled by a particle is like this. That is equal to 3a by 2 plus 7b by 3. The most important thing, everyone try to understand once again. If the velocity of the particle is given, how do you get the distance traveled? Which is quite opposite of differentiation. So that we have to apply the integral concept here. That is, the velocity is the rate of displacement. Later do the integration on both sides. Right. We will take one more example. How can you apply the integral concept in motion in a straight line? See, try to understand one more application. How can you apply the integral concept in motion in a straight line? The velocity of a particle is given like this. What is the velocity of a particle? V is equal to V naught plus gt plus ft square. This is the given expression. The velocity of a particle is given like that. V is equal to V naught plus gt plus ft square. One condition is given in question. What is first condition? The position of a particle is 0, x is equal to 0 at a time t is equal to 0. Then what is the displacement after t is equal to 1 seconds? This is x1 value is given. What is x2 value? X2 becomes what? Now, same principle. If velocity is given, how do you get a distance traveled from that? If velocity is given, distance means integration. Everyone remember that order once again. From displacement you got velocity. From velocity differentiate once again you got acceleration. But integration is reverse. Remember it. If velocity is given, how do you get a distance traveled from that? By doing integration. That is the important point. Now, velocity is given like this. Let us take this is first. But velocity is what? The rate of displacement like this. The rate of displacement is called velocity. Now if you observe this 1 and 2, here both left hand sides are equal. If the left hand sides are equal, you can equate the right hand sides. Now let us equate right hand sides. Therefore dx by dt is equal to what? Dx by dt is like this. Here both left hand sides are equal, so that equate the right hand sides like this. Therefore dx by dt is equal to v naught plus gt plus ft square. Now do the cross multiplication. Dt can be taken to right side. That is v naught plus gt. V naught plus gt plus ft square into dt. Now how do you get x2 value from this? Do the integration on both sides like this. Integral dx is equal to what? That is v naught plus gt plus ft square into dt. You can write like this. Here starting point is what? Starting point is 0. That is the lower limit. And let us take this is 0. And what is final point? Let us take this is x2. So the limits are taken like this. That is important point. Starting from 0, let us take the ending point as x2, so that you can write 0 to x2. What are the limits of time given in question? Starting from 0, that is the lower limit. Ending at what? T is equal to 1 second. That is the upper limit. So that you can write like this, 0 to 1 second. 0 to 1 second like this. Now, you can apply this mathematical formula now. Integral dx means what? X. What are the limits? 0 to x2. Here you can split into 3 integrals. Then you will feel comfortable. How can you split? First one is what? 0 to 1 v naught into dt plus. Second one is what? 0 to 1 gt into dt. That is second integral. What is last one? Integrals 0 to 1 ft square into dt. Observe this. The entire integral can be split into 3 different integrals like this. Now you can apply the integral formula at this stage. Integral dx is x. What are the limits given? 0 to x2. Observe right side. What is first integral? V naught is taken outside. You can take v naught outside. Integral dt means what? T. Integral dt is t. What are the limits here? 0 to 1. After applying the integral, limits will come to the right side, 0 to 1. G can be taken outside plus G into integral t power 1. T power 1 means x power n formula. Integral x power n formula, you know, that is x power n plus 1 by n plus 1. I repeated once again, everyone observe this formula careful. Integral x power n into dx is like this. X power n plus 1 by n plus 1. So that what happened here? If you take g outside, integral t power 1 into dt, that means you can write t square by 2 between the limits 0 to 1. Last term, observe it. F can be taken out. F can be taken out. Integral t square into dt means what? T cube by 3. After applying that integral, limits will come to the right side like this. T power 2 plus 1 by 2 plus 1. T cube by 3. Right. Now, apply the upper limit minus lower limit at this stage. X can be replaced by x2. See here. X can be replaced by what? X2 minus 0. Upper limit minus lower limit. Right side first part, that is V0 into t is variable factor. Upper limit minus lower limit. V0 into 1 minus 0 plus G into t square by 2. Substitute t is equal to 1 first. Minus t can be replaced by 0. What happened? That is G into 1 square by 2 minus 0. Last one. That is F into t cube by 3. 0 to 1. Substitute upper minus lower limit. What happened? That is 1 cube by 3 minus 0. Therefore, finally you get like this. The distance traveled is what? V0 plus G by 2 plus what? V0 plus G by 2 plus F into 1 by 3. So you can write that is F by 3. The distance traveled by the particle is like this. Here, this is a very important mathematical formula. Remember, throughout the chapter we will apply this one. Integral x power n into dx is x power n plus 1 by n plus 1. Right.